Okay, ladies, we are on day 7 of our packet. Almost there, just one day left. We are looking at linear equation application problems. So basically, we're taking what we did in this unit and now we're applying to real world scenarios. We are going to look on page 16. So we're going to skip Micaiah. And we're going to talk about the temperature falling outside. So first thing we do, we're going to read. Temperature is falling outside at a steady rate of 4 degrees Fahrenheit every hour. The temperature starts at 68 degrees Fahrenheit. Complete the following. So I'm going to read it again, and this time I'm going to highlight some important facts. Get my pen ready. Okay, the temperature is falling outside at a steady rate of 4 degrees Fahrenheit every hour. The temperature starts at 68 degrees Fahrenheit. Complete the following. Okay, so let me just go back in and think about some things that I highlighted. Well, if the temperature is falling, I know something is going down. So I could say something is decreasing, right? And it is at a steady rate. So that means constant. So I know that whatever I'm working with, I'm definitely working with something that is linear. And it's going down 4 degrees every hour. And something really important, that it starts at 68 degrees. So I already went back in, I highlighted some important facts, and then I went back and double annotated and pulled out some of that important math stuff. So letter A, write a linear equation that relates to the Fahrenheit temperature F to the time in hours T that it has been falling. Well, if I'm working with a linear equation, I know that it's going to be y equals mx plus b. Well, I really need to establish what is my domain here and what is my range. Well, here I could say that my domain, which is an independent variable and it's something that cannot be changed, will really have to be the hours. So I know that my hours are my domain, which essentially is going to be my x values. So here, instead of t, instead of x, I'm going to have t. So m is still my slope, and I'm still going to have my starting point. And my y, that's really my range, it's something that's dependent, and that is the temperature, F, Fahrenheit temperature. That is definitely dependent on the time and the hours. All right, so I have what my equation needs to look like. So let's start plugging in some stuff. Well, I'm still going to have, let me change my color. Hold on. Now that I learned how to do that. So F equals, well, what's my slope here? Well, that's that constant rate right here, and it's decreasing. So I know that it's falling, it's going down at 4 degrees every hour. So T's my hour. And if it's going down, then I know it's being negative. So -4 plus, well, where are we starting at? We're starting at 68. So there is my equation. Okay, letter B. Fill out the table for the outside temperature during the times it's cooling down. Then graph the equation on the grid below. Grid provided. Okay, let's start with the chart. So at 0 hours, right, that's my starting point. Okay, the temperature is 68. After the first hour, it's going to decrease by 4, so 64. Right, so so from here to here, it's -4. Each time, it's going down by 4. So, and the second hour, after the first now, it's at 60. The third hour is at 56. Now look right here, they try to trick you. They're giving you hour 7 and hour 8. So after hour 7, I can either keep going and figure out what's 4, 5, and 6, or I could always plug it into my equation. F equals -4 times 7 plus 68. And I could use my calculator. That's going to tell me 40. And then to find 8, it's 36. Right? Because from here to here, it's -4. Alright, now I have my table. And I'm going to go here. And I'm going to have to go, get rid of that. Okay, I'm just going to go a little bit like this for right now. So they give me a blank grid. Well, to graph it, I really have to be able to label my axes and also create them. So here, this is definitely going to be my Y, or in this case, F. Right, that's my range, and in this I can label it as temperature. Probably say that. And then over here, I'm going to have my x-axis, but in this case, my t, my time. So I'm going to put down hours. Okay. Now, if you're looking at this, why are we only focusing on one quadrant? Why don't we have any numbers here and any numbers here? Well, can we have negative time? No. And can we have negative temperature? Sometimes we have like below 0. We say feels like -17 degrees. But usually when we're graphing it, we really just don't use it as much. Okay? In this case, we're not really there yet. So let's think about how we're going to scale this. Well, how many lines does this have? If we were to count it, we would say it would be 20 by 20. Well, here we could definitely start by the first hour and go up by ones. So 1, 2, get to the 20th hour. And your temperature, well, if we start at 0, we go up by 1, we're only going to get to 20. And we're really trying to get to 68. That's our starting point. So you got to think about, well, what would be the best place to start, where you'll definitely get 68. If you go up by 2s, that'll get me 40. If you go up by 3s, you're going to get 60s. You're going to get 60, so you're getting closer. If you go up by 4, you're going to get to 80. So that's a good one to use. So if you start with 4, up here would be 60. Next one would be 8. Okay? I say 60, I meant 80. Alright, so let's start plotting some points. Well, let's start our starting point, which would be 0, 68. That's 80. 76. 72. 68 would be right there. And then after first hour, it would be 64. The second hour would be 60. The third hour would be 56. We could just keep going, and then it would be, you see the balance is going down by 4. We could kind of just use our slopes and say R by 4. basically just going one box at a time. You could probably just make this go, all the way. And you could draw your line. Now, am I going to have arrows? No, because we're not going into negative time. And we're not going to go into negative degrees in this scenario. So we're just going to keep it just like this. Okay? Now let's go down to our last questions. Which says, according to your equation, what temperature when T is equal to 2.75 hours? Where can you find this information on the graph? So let's just think about where we would find this on the graph. If we were to look at this on the graph, well, we're basically looking at the hours between 2 and 3. And it's a little bit more closer. I'm just going to pull this down a little bit so we can see. So we're just really looking at it right here. 2, between 2 and 3. No. 2 hours, 2.75 hours. It's a little bit closer to 3. So I would say maybe, possibly, it's somewhere around here. So if you're looking at this question right here, you could always say, where can you find this information? You could say between hours 2 and 3, closer to 3 hours. Okay? Now, if you're looking at this one, according to the equation, what is the temperature when T is equal to 2.75 hours? Well, let's plug it right into our equation, which is F equals negative 4T plus 68. And if we were to plug this in, T is 2.75 plus 68. That's a 2. And that's a negative. Okay, and if we were to use our handy dandy bestie to find F, we would say that F is equal to 57 degrees. Oh, oops, I didn't mean to do that. Oh my goodness, I can't make that F. Fahrenheit. Okay. Now let's look at D. It says, if the cooling continues at this constant rate, how many hours would it take for temperature to reach freezing? Well, you need to know how much is freezing, and freezing is actually 32 degrees. So we're looking for it when it's at 32 degrees. Now, it's telling you to show your work. So that means they want you to do this algebraically. So 32 is our F, our degrees, is equal to negative 4 times T, because we don't know the hours, plus 68, right? So minus 68 on both sides. Negative 36 equals negative 4T divided by negative 4 on both sides. I'm just going to put the answer here. T is equal to 9 hours. Don't forget your units. Now, if you always want to check yourself, you could go see. So you could go over to hour 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're looking at it right here. And at this point right there, if you're going out 4, 8, 12, 16, 20, 24, 28, 30, is that 2, 3, 4, 5, 6, 7, 8? Yep, right over here. That is 32. All right, so this one had a few parts to it. And Micaiah's question just has 4 points, just like this one. So what you should be doing now is using the strategies and techniques that you learned in this one and using it in the one on page 15.